Hello and welcome to Pint of Science 2021. We're live from Norwich, the home of University of East Anglia. So my name is Catherine and I'm a master's student studying developmental psychology, and I'm excited to be hosting tonight's show. We may not be in our usual setting, but it does come with its benefits. So being online means you can tune in from anywhere in the world. So let us know in the comments where you're joining us from and what you're drinking. I've got a cider in hand ready waiting. You can also get involved tonight using Twitter hashtag Pint21 and at Pint of Science. And if you'd like to know any more details about tonight's show or the rest of the festival, pop over to pintofscience.co.uk. So, sleep, something we all wish we had more of. We spend roughly a third of our lives asleep, and it's essential for good health. So with that in mind, our speakers tonight will take you on a journey from infant sleep to teenage sleep, finishing up with how to take control of your dreams. We'd love for this show to be very interactive, so let us know what your sleeping habits are like. Are you a night owl or are you an early bird? And we'll come back to your responses later in the show. More importantly, do let us know if you have any questions for us. So without further ado, grab a pint of your favourite tipple and let's move on to the main event. First up, we have Dr. Teodora Gliga. She's an associate professor in psychology at the University of East Anglia, and she'll talk about why infants sleep for so long, yet not long enough. Take it away.
Thank you, Catherine. And thank you everyone for being here. Especially thank you to those of you who are parents of young children for still being awake this hour, for having managed to put your children to bed, or having used this lecture as an excuse not to have to put your children to bed, like I did tonight and Catherine. So parents or not parents, we probably already all wonder at some point, why do we need to sleep? Why do we need to get into this state in which we're unresponsive to the outside world? We cannot hear, we cannot see. There must be a really good reason to make ourselves so vulnerable. And I think the answer to this question really lies in development. The length, how long we sleep for changes dramatically throughout lifespan. When we're born, we sleep for as much as 16 hours, and the amount of time we spend asleep remains quite high throughout childhood and only decreases later in adolescence. And there's one other thing that children have to do a lot, and that is to learn. So in this talk, I'm going to tell you how we sleep scientists go about showing that sleep is for learning, and I'll give you some examples from language development. And then we will ask the question why we need to sleep in order to learn, and we'll have some examples for motor development. And then I'll give you a snippet of my own research into sleep and why some infants are not such good sleepers. And we're going to look at the link between sensor sensitivities and sleep in autism, and how we can help infants to sleep better. So how do we know that sleep is for learning? Well, we often do this by using experimental paradigm called the sleep-dependent learning paradigm, very long name. But what happens in these studies, whatever age you're looking at, you would first teach something to your participants. So if it's a child, you could, for example, teach them a new word. This is a ball, and then you would split the participants in two groups. There will be a group that will sleep or take a nap, and there will be a group that would stay awake. And then once the first group wakes up, and at a similar amount of time after learning in the awake group, you would ask both these groups of children whether they remember the information that you taught them earlier on. So for example, they would have to point to which one of these two objects is the ball. And what we know is that from a lot of similar research studies that learning benefits from sleep, from nap in this case. So babies that had napped would remember better this information than babies that had not, that stayed awake. But more interestingly, they will not only remember that this round thing, yellow thing is a ball, but they will be able to generalize this information to a new ball. So what this tells us, and what we now know, is that sleep is not just for consolidating information, but sleep actually makes information less context dependent, allows us to generalize, and even to come up with new solutions. Now, children's sleep is interesting not because they sleep a lot, but they have these bouts of short sleep during the day, which we call nap. So why do babies have to nap? Well, we know from studies that looked at the number and duration of nap that it's really the frequency, how many times they nap, that matters, and not the duration. And so what we believe now is that children need to sleep soon after learning for knowledge to be consolidated. And this is why they have to go through this alternation between learning and sleeping and learning and sleeping. But naps disappear at some point in development. Between 2 and 3, children would stop napping, and that's when parents get a bit anxious. Should we try to make our child sleep? And the answer is actually no. So the reason that children drop this nap is because they at some point do not need to nap in order to learn. So we know this again from a similar study in which we had children that had stopped napping and children that were continuing to nap take part in this sleep learning paradigm, and only those children that were still napping benefited from naps. So children stop napping when they don't need to nap to consolidate information. Now, why do we actually need to sleep in order to learn? And to answer this question, we need to look at the brain. And there are 3 structures in particular that are important for sleep. One is the hippocampus, and the hippocampus stores information while we're awake. The other is the cortex, and the cortex stores information longer term. And what we think sleep does is that during sleep, the hippocampus replays memories and events that happen during the day in the cortex, which leads to the consolidation of this information. Now, interestingly, in children, the hippocampus is not mature, so you cannot store a lot of information while they are awake. And we think this is why they need to sleep soon after they learn. This is why they need to nap, in order not to lose this knowledge. But I said there was a 3rd structure, so that is the thalamus. The thalamus is actually the structure in the brain that receives all the sensory input, hearing, touch, visual input. But during sleep, the thalamus actually gates or prevents sensory input from reaching the cortex. And we think that this is actually critical for the replay of memories. So in order to use the cortex to replay memories that you have acquired while you are awake, in order to consolidate them, well, you don't want the cortex to be busy doing something else. So basically, the reason we sleep is because we want the cortex to be able to dedicate its activity to consolidation rather than to processing whatever happens in the environment. Now, I really love this example of why sleep is such a unique opportunity for learning. So we're looking here at sleep twitches, and we all twitch from time to time during sleep, but newborns twitch quite a lot. So twitches are quite complex movements of the arms or the legs or the face. And here you have an example of a twitch in a neonate. So you'll see this little child is going to move the arm. And you see here also in the electroencephalogram, so this is a recording of the brain activity. You will see how the movement is affecting the brain activity. So here it comes. Twitch and the little activity in their electroencephalogram. So newborns do this a lot, and now we believe that this is actually a way for them to learn about their bodies. So basically, when we're born, the brain doesn't know that we have 2 arms, 2 legs. The brain doesn't know how the arms and legs can move. So by producing these twitches, it's a way in which the brain can learn about what the body is able to do. And you may ask, so why aren't these babies learning while they're awake and moving about the environment? And of course they do that as well. But of course, thinking of a neonate and their limited motor abilities, and the fact that when you are awake, you want to move in order to interact with the world, it's really not the time to try out new or complex movements. So the brain uses sleep in order to maybe try out new things, more complicated movements, in order to learn about the body. So babies sleep a lot, and many babies seem to fall asleep very easily, but this is not the case for everyone. And some of my research is looking into the early development of infants that have a higher likelihood of developing autism. So these are infants that have an older sibling with autism, and we know that about 20% of them will develop autism themselves. And we know that these infants have poor sleep and have poor learning also. And we also know that they struggle to filter out sensory input. So, for example, in one of the studies we did, where we showed a stimulus, a little tactile stimulus repeatedly, typically developed infants habituated to this repeated information, they responded less with repetition, but the infants with latent ASD did not show this habituation. So one of the hypotheses we're testing at the moment is whether poor gauging of sensory input explains poor sleep in infants with later autism. And so in one of the studies that we did, we looked at the impact of this ability to habituate to repetitive stimulation and whether it predicted how long it would take infants to fall asleep. And we find a positive association in the sense that those that were poor habituators, or the infants that did not habituate, took much longer to fall asleep, up to 30 or 40 minutes. Of course, I want to take this opportunity to say that we are still recruiting infants with an older sibling with autism. So if you are in the Norfolk area and you know someone who might want to take part in our studies, please get in touch. Now, of course, the main reason why we're doing this research is because we want to understand how we can help these infants sleep. And there's probably no richer source of knowledge than that acquired by parents in the first months of life. Babies and parents learn about each other a lot. So in one of the studies that we're doing at the moment, we want to tap into this parental wisdom and ask parents what kind of strategies they employ to make their babies fall asleep. And this picture with the baby and the running tap, this is actually something that I know a few people have tried. So we simply ask parents to tell us how often they use various strategies to make their babies sleep. And here's a selection of those. So they had to answer 0, never, to 4, always. And as you can see, parents of 4 to 7 months old babies use a variety of strategies. And I've highlighted here those that seem to be more frequent. And you recognize some that you might have thought of as well: stroking, rocking, feeding. But there's also playing white noise, which is quite popular, giving a dummy. There are also the fortunate parents who have babies that settle on their own. Congratulations. So this is interesting, but of course the question that we want to ask now are, do these popular strategies actually work? So are they chosen because they are really successful? And what is it about certain stimulation that makes it so sleep-inducing? And possibly the answer to the second question will need to take us back to the brain. So I told you that there are 3 structures that are involved in producing sleep and allowing memory consolidation during sleep. And in order for these 3 structures to work together, they need to be tied together. And the cortex does this by producing slow waves, which are waves between 0.5 to 4 hertz. So that is something that happens every 2 seconds up to 4 times a second. And by using these slow waves, the cortex actually allows the hippocampus and the thalamus to work together. Now, think of some of those strategies that parents use to help babies fall asleep. For example, rocking. Well, one of the questions that we're pursuing and that our researchers are pursuing is whether this type of stimulation to use is actually helping infant's brain create slow waves, because the stimulation itself occurs at the rhythm of these slow waves. And there are more questions and answers in this talk. I believe the science of infant sleep is really in its infancy. So hopefully you will hear more from us. And I'm happy to take your questions now. And thank you to my lab, Anna, Achilleas, Hope, and Abby.
Thanks, Taya. That was fantastic as always. So we currently have no questions for you, but we do have 150 viewers at the moment. How's that feel?
I think, I don't know if I've ever had so many viewers.
So what we'll probably do, if that's all right with you, is if you want to stick around to the end, we'll wait for any questions and we'll do a Q&A session at the end. Is that okay with you?
Yeah, of course, yeah.
Brilliant. So thank you. So let's see where people are joining us from. So we've got some people from Norwich. Hello. We also have some international viewers all the way from Hague and Italy, I believe. So it's lovely to see that we are getting across the waters. So, well, for our next speaker, we've got Dr. Jo Bauer. She's a lecturer in psychology at the University of East Anglia. Hiya. And she'll be talking about our bugbears of many parents. Why do teenagers stay up late and sleep until noon? Take it away.
Hi, well, thank you all for being here. It's really exciting to know that we have managed to get across the waters one way or another, because it doesn't sound like we'll be travelling there ourselves anytime particularly soon. So today I'd like to follow on from Taya by moving us forward a decade or so and talking about teenagers and some of their sleep patterns. But before we do that, I'd like you to take a minute and just think to yourself, well, how would you describe a stereotypical teenager? And while you're thinking about that, I'm going to give you some of the answers that some of my students gave me a few weeks ago when I posed that question to them. And so that one of the first things they came up with was, well, a typical teenager is seeking freedom. They want to develop their autonomy. They want to push the boundaries. They're trying to break free of rules, like create their own identity. And as part of that, one of the things that a lot of people might identify with is that teenagers will often put their friends before their family. So they'll seek out new friendship groups, potentially they'll start to create romantic interests, and quite often you'll find that whereas perhaps a younger child will always turn to their parents for comfort and for support, teenagers will often turn to their friends or to peer groups as well. And in amongst these all positive things, we also see a few things that are a little bit more difficult to deal with. So a lot of you might say, well, yeah, a stereotypical teenager is kind of emotional and kind of moody. And so, I mean, I think back to my own teenage years. I'm convinced I was a delight. My parents might well tell you something different. But certainly in amongst seeing all your new friends and seeking your new freedoms and pushing your new boundaries, you're actually under quite a lot of pressure. So that pressure can come from like trying to navigate these new peer relationships. It can come from like school pressure. It can come from a range of other different sources. And all of this is happening whilst at the same time we're trying to like navigate brain development as well. So Tia did a really nice job of talking about how different areas of the brain can talk to each other from like knowledge consolidation. And exactly the same thing is true when we think about memory as well. And so, I'm sorry, about emotions and stuff as well. So the way we regulate our emotions in our brain can change while we're a teenager, and those things all change. And then one of the things that this leads to is quite often teenagers being really tired and like quite often being sleepy during the daytime, or like we say, wanting to stay up all night, wanting to be up late and sleep late into the morning. And so why am I telling you all these things about teenagers that may or may not relate to you and may or may not like identify with what you already know? Well, what I'm hoping to show you in a minute is that a lot of these things might also feed into why it is that teenagers find it difficult to sleep sort of early into the night, and why quite a lot of teenagers will have some kind of sleep problem, or will at least want to go to bed far later than you wish that they would go to bed. But also others of these can be things that come up if you have poor sleep. So things like being emotional or moody, or feeling like it's hard to deal with pressure, being tired or sleepy, can also be symptoms of poor sleep. And my screen seems to be moving away ahead of me. But this all comes into a model that we call the perfect storm. And this was developed by a lady called Mary Caskoden. She was quite big in America when she was does a lot of work with teenagers and teenage sleep. And what she's identified is that there is this perfect storm of things that happen in teenage life that means that sleep often suffers. And so, for example, when you're when you're a teenager, your biology changes. So you have in sleep 2 different processes that help control sleep. We have our body clock, so we call that our circadian rhythm. And what that does is it controls the timing of sleep. So you might have heard of melatonin, which is a hormone that we release to say, okay, it's time to go to sleep now. So we release it late at night. And that helps sort of prompt sleep at nighttime in one consolidated period. And then you're awake during the daytime. And so it's this body clock that also feeds into things like having jet lag, or why some shift workers find it quite hard to sleep sort of during the daytime. And then alongside our circadian rhythm, we always also have what we call our homeostatic drive. And homeostasis just means bringing things into balance. And so quite simply, if you've been awake for a very long time, your pressure to sleep increases. So you're much more likely to go to sleep. And conversely, if you've been asleep for a long time, then your pressure to wake up increases. And so those 2 systems, your homeostatic drive and your circadian rhythm, work together to help you sleep at nighttime. But in teenagers, what happens is that your circadian rhythm delays. And so whereas as adults, we might start secreting melatonin at say 10 or 11 o'clock at night, in teenagers, that can be quite a lot later. And so if you haven't got this hormone saying, I'm sleepy now, it's time to sleep, then it's not really that surprising that teenagers then want to stay up later into the night. And we can combine that with the fact that the sleep pressure also rises more slowly. And so again, whereas we've been awake, say, for 16 hours, we've got quite a high pressure to sleep. For teenagers, that might extend over, say, 18 or 20 hours. So we've got, again, these 2 biological systems that are both working together to delay when the sleep onset arises. So combine that then with psychosocial factors. So things like teenagers have autonomy quite often over their bedtime. Certainly, I remember my parents getting to the point where they were just like, okay, well, we're going to bed now. Please don't be too much later. Turn all the lights off. And it was up to me, like it is with many teenagers, what time I chose to go to bed. And so that bedtime autonomy leads to people going to bed perhaps later than they otherwise would do. There's also things like academic pressure. So as you become a teenager, you get more and more homework to do. Potentially, you've started taking on a part-time job that takes up time as well. There are more and more demands on your time that means that perhaps you need to go to bed later to get everything done. And then you have those social things. So remember, the peer groups are really important to teenagers. Well, perhaps teenagers want to spend more time on social media or TikTok or interacting with their friends. And to do that, quite often you end up in front of a screen for quite a long time. And so the screen time can be problematic because that releases something called releases blue light, and that can delay our melatonin onset. So I'm sure you've heard a bit about perhaps like blue light being a bit of an issue, and sort of people promoting things like blue light blockers or telling people not to use electronics in the hour before bed. And that's why, because it can delay our sleep even further. And so we've got a cacophony of things that are working together then to delay when a teenager wants to go to bed. But what happens at the other side of the coin? Well, the problem we've got is that we've got certain things that are removable. So the time that school starts is not something a teenager can dictate, and schools tend to start fairly early. And so we've got biological and psychosocial things that are saying, let's go to bed later, but we've got school start times that are saying, no, you've still got to get up early. And what that means is, certainly during the week, we end up with teenagers that are going to bed late and getting up early. And that results in not getting enough sleep, and also potentially be getting sleep that is not at an ideal time compared to your circadian rhythm. The other thing that can happen is that quite often on weekends, what we'll then see is like a recovery sleep. So on the weekend, a teenager quite often is free to choose their own bedtimes and their own wake times. So potentially a teenager will go to bed at 1 or 2 in the morning, sleep through till noon or 1. And what that means is it's great in that they're getting a little bit more sleep and they're getting some recovery sleep, and that can be really beneficial. But it also means that their circadian rhythm, again, is not very stable, because you're sleeping at one time during a couple of days of the week and a different time for the other 4 or 5. So it can also make it slightly more difficult to get into a rhythm of early to bed, early to rise. And why do we care? So why does it matter? If all teenagers don't sleep very well, they'll grow out of it. What's the issue? Well, some of those other things that we were talking about, like feeling like they're under pressure, feeling like they're moody or emotional, these are things that can come up when you don't get enough sleep. And we know in adults, in children, and in adolescents in particular, poor sleep can lead to things like worsened academic performance, poorer mood, increased things like anxiety, depression, and increases in risky behaviours. So things like drink driving, you see a lot more of in teenagers that only get, say, 5 to 6 hours sleep. And there's a nice example of this on this graph here on the left. So what's happening here is the graph is showing how many errors people make on an attention task. So how many times they miss a prompt that they should have responded to. And you can see these red and green lines that are coming up at the top when they've had 5 hours sleep a night or 6.5 hours sleep a night over the 5 days that they've, over say a school week. Then they've got a couple of recovery nights where they sleep 9 hours, and then another few days where they're only sleeping for 5 or 6.5. And what you can see is these errors just keep going up over these 5 days. They get a little bit better when you recover, and then they go up even further, particularly in the 5 hour sleep in the following week. Conversely, these lines in the middle are what happens if you then allow a teenager to nap in the early afternoon. And you can see that there is some drop off in performance and a little bit of recovery, but we're still seeing that performance is impaired, albeit not so much. And if you compare that towards, say, the bottom line here, which is where someone's getting 9 hours sleep throughout, you can see that there's quite a big difference in how they're performing on this particular task. And these kind of events have been sort of replicated across several different cognitive tasks, so several different aspects of academic performance, like memory or reaction time or attention. And we also see similar graphs that sort of show far more irritability, far more low mood, things like more oppositionality, so being just a little bit like harder to sort of reason with and sort of to tell what to do when people don't get enough sleep. So to finish off then, having just sort of painted a picture of doom and gloom about how terrible teenage sleep is and how awful that is for their development, the last few minutes I just want to talk about, well, what can we do about it? And I think we can do things on several different levels. So there have been studies all over the world now that are looking at delaying school start time. So on a societal level, there's a whole movement about it in America. There's been some studies here in the UK, and there's been studies in other places like sort of Singapore, Hong Kong, in sort of Asian countries as well. And what we're seeing the world over is that if you delay school start times, unsurprisingly, teenagers get more sleep. So it's not just that they go to bed even later, they do actually get more sleep. But even better than that, not only do they get more sleep, but there's less truanting, there's less absences, there's less late times, there's improved mood, improved anxiety, improved exam and like school sort of school results as well. So we're not just seeing an improvement in sleep at night time, but we're also seeing an improvement that follows through into daytime functioning. But that says, as an individual, it's very difficult to change school start times, right? But that doesn't mean there's nothing you can do. There are some individual things that we can do as well. One of those is, for example, limiting device usage in the evening. So if you're on your laptop and your tablet and your phone and various other things, if you can try and limit that, particularly in the hour before bed, you're then reducing your exposure to blue light. And by reducing your exposure to blue light, hopefully that means your body clock will start to come a little bit earlier. There's also things you can do, like when you wake up in the morning and trying to get up and outside and into daylight as soon as possible can also help reset your body clock. And then for people who are really, really severely affected, so perhaps they're not going to bed until 3, 4, 5 in the morning, even on school nights, there are also other things that people can do. So we can do things like light therapies, where we give people light boxes for the morning that help sort of resync them. We can do things like sort of shifting their bedtime back very, very gently until they sort of like get back into a sort of more typical routine. And then there are things that all of us can do, adults, children, teenagers alike, which we call good sleep hygiene. So things like making sure that your bedroom is relatively dark, making sure it's quiet, making sure that it's a fairly cool temperature. We sleep best when it's fairly cold and we have a thicker duvet over us. Making sure we've got a comfortable environment, that we're not using bed for also studying and reading and watching TV and a bunch of other things. We're just using bed to sleep in. And by following all of those things, we can hopefully improve sort of teenage sleep. And by improving teenage sleep, we can then improve their daytime life as well. So thank you for listening. It's a very short whistle-stop tour, but I'm very happy to take any questions as soon as you've got them.
Thanks, Jo. That was fantastic. So very interesting. I hope some parents out there have got a few answers to their questions. So you'll be sticking around as well for questions after the last talk?
Yeah, absolutely.
Well, we'll see you later then. Thank you. So on the topic of good sleep hygiene, what have we got in terms of sleep rituals? Have any of you got any really quirky sleep rituals, or any of you pretty normal like myself? I like to read before I go to sleep. So let's hear from you. Don't forget to comment in the comments below. And also, if you have any questions, do let us know. We've got some really, really good ones coming in at the moment. So we're now looking at our final talk today, and this is all about how to control your dreams. And this is presented by Research Associate Achilleas Pavlou. So take it away.
Good evening, everyone. My name is Achilleas Pavlou, and I am a research associate at the University of East Anglia. Today, I'm going to talk to you a little bit about the topic of lucid dreaming. We will briefly go over what is currently known in the field, and towards the end of my talk, I'll share a combination of techniques that you can try at home in order to lucid dream more frequently. I will close by sharing some of the findings from my PhD thesis, which resulted in a novel lucid dreaming induction protocol. So let's dive in. So what is lucid dreaming? Lucid dreaming refers to the phenomenon whereby a dreamer is aware that they are dreaming. So therefore, in a lucid dream, it is possible to wake up deliberately or to influence the action of the dream actively, or to observe the course of the dream passively, knowing full well that what is experienced is nothing but a dream. In order to quantifiably assess dream lucidity, the 8-factor lucid scale was developed by Voss and colleagues. In this questionnaire, the insight factor refers to how aware one is that what is experienced is a dream. Control refers to how able one is at controlling their actions or their dream environment. Thought refers to thinking about your own dream actions, characters in the dream, and things that are happening in the dream. Realism refers to the similarity between emotion, thoughts, and experiences between the dream scenario and waking life. Dissociation refers to being able to experience a dream from we call it a disassociated standpoint, as if you're observing the dream in a third-person perspective. And finally, negative and positive emotion refer to the intensity of emotions experienced whilst dreaming. So using this lucid scale, a clear distinction is made between lucid and non-lucid dreams. Non-lucid dreams score low on most lucid factors, especially on insight, control, and dissociation, which are the 3 most leading factors in dream lucidity. Lucid dreaming is thought to be a rare occurring phenomenon that arises from REM sleep, the sleep stage that is most associated with vivid dreaming. A recent meta-analysis that has pulled over 50 years worth of studies with a huge sample size of 24,282 people has shown that the proportion of individuals who have experienced at least one lucid dream in their lifetime is 55%, and that 23% experience lucid dreams once a month. This finding suggests that the capacity for lucid dreaming is widespread. When it comes to the neurobiological correlates of lucid dreaming, when comparing normal versus lucid dreams, neuroimaging studies have shown that lucid dreams exhibit higher gamma band activity and increased activation in the frontal and frontotemporal regions of the brain. The increased activity in these regions is thought to explain the higher consciousness exhibited by lucid dreamers, as these areas are involved in higher cognitive processes. So essentially, the brain activity whilst lucid dreaming is closer to the brain activity exhibited when we are awake. In contrast, in normal dreams, the frontal parts of our brains is largely deactivated. This is why normal dreams were usually more emotional, more impulsive. We have decreased critical thinking and minimal access to the biographical memories. This is why we don't realize that we're not a character, for example, in Game of Thrones, and that we were just asleep an hour ago. So basically, during the 70s, it was theorized that lucid dreaming reflected brief awakening periods in the night. But since then, it has been debunked through the use of various psychophysiological measures, which demonstrated without a doubt that the person is asleep while they're lucid dreaming. Moreover, using a variety of psychophysiological measures, we're able to associate things that are happening in a lucid dream. For example, whilst dreaming, our eyes move behind our closed eyelids to wherever we're looking in the dream. That's why it's called REM sleep, which is short for rapid eye movement sleep. So in lucid dreaming research, eye movement patterns that are decided upon prior to sleeping with the experimenter, between the dreamer, the lucid dreamer, and the experimenter, have been used to signal dream lucidity in real time to the researchers, as well as signal the beginning and end of completed dream tasks. So recently, Concoli and colleagues did this two-way communication protocol where they were able, for example, to send simple auditory mathematical equations for lucid dreamers to solve. In several of these instances, lucid dreamers were able to hear them whilst dreaming. Subsequently, they then signaled the answer back to the experimenters with their eyes. For example, to answer the equation 1 + 2, they had to move their eyes left to right 3 times to provide the answer 3. The authors also had an experiment where participants answered yes or no to questions such as, do you watch football? Upon receipt of these questions, lucid dreamers were instructed to move different facial muscles in their dream to signify a yes or no answer. So they were able to answer these questions as dream movements can cause small muscle twitches, which can then be picked up through sensors that are placed over those facial muscles. So while lucid dreaming is a novel and entertaining topic that is fun to experience, it has very real applications on health, well-being, and consciousness research. Studying the lucid dreaming state can give us valuable insight into how consciousness is formed, for example. Furthermore, the therapeutic interventions using lucid dreaming therapy have demonstrated alleviation of symptoms in post-traumatic stress disorder. So people who have PTSD, post-traumatic stress disorder, they experience vivid and recurrent nightmares that heavily impact their sleep quality and daytime activities. So by realizing that, what is experienced during a nightmare is not real, the person can then change the dream content into a positive or a neutral experience, and therefore eliminate or reduce the frequency of nightmares and improve their sleep quality. Moreover, there's some exploratory research that has demonstrated that lucid dreams can help improve motor skills, and this could be applied in sports training, sort of acting as a lucid form of mental rehearsal training, a technique that is typically used by pro athletes. So can lucid dreaming be induced more often? And the answer is, sorry, that's the wrong slide. So lucid dreaming research has looked into what makes someone more likely to lucid dream. One of the strongest correlates is the ability to recall dreams frequently. This is something that should not come as a surprise, as the more dreams someone can successfully recall, the more likely it is they are to recall dreams that were lucid. But perhaps more interestingly, dream recall frequency has been correlated with neurobiological differences in brain activation patterns that are favorable for experiencing lucid dreams. Overall, studies investigating lucid dream frequency correlates showcase a relative continuation of cognitive and metacognitive ability from wake to dreaming consciousness. So a higher cognitive and metacognitive ability during wake has been shown to facilitate the likelihood of experiencing lucid dreams. And this is the slide. So if you've never had a lucid dream experience or wanted to experience them more often, I have good news for you. Lucid dreaming is a trainable skill, and there's several lucid dream induction techniques that have been developed to increase the frequency of lucid dreams. Lucid dreams have been induced through cognitive and external stimulation techniques, as well as through the use of pharmacological interventions. Specifically, cognitive techniques are techniques that you do during the day or whilst falling asleep that can help incubate a lucid dream to happen. External stimulation techniques, they use stimuli such as visual, tactile, or audio stimuli during REM sleep in order to induce lucid dreams. So stimuli such as, audio, visual, tactile, they tend to become incorporated into the dream content and can then trigger a dream lucidity by alerting the dreamer that they are dreaming. And then with drug applications, there are some, particularly a drug called galantamine that's used in Alzheimer's disease that helps activate brain areas associated with lucid dreaming. And it's been shown promising results. So I will now share with you 3 cognitive techniques that you can try at home. So one is the reality check technique, which refers to asking oneself regularly throughout the day whether you're dreaming or not, and examining the environment for possible incongruences. So a common reality check technique that is used is pinching your nose while trying to breathe through it, which obviously is impossible because you're blocking your air, the air passage. But however, if you do this several times a day, you increase the likelihood of dreaming about the reality check, which, if you do this while dreaming, if you try to pinch your nose and try to breathe through it, you'll actually be able to breathe through it because you're not actually physically blocking your nose. Another technique is the wake back to bed method, where it is suggested to wake up 2 to 3 hours before your actual wake up time and to stay awake for a brief time and then go back to sleep. And this has been shown to increase the likelihood of lucid dreaming. And the reasoning behind it is that the brief awakening is thought to increase is thought to make you go back to sleep, but with a more activated cortex, which then is beneficial for, which then facilitates dream lucidity. So a testament to the effectiveness of this technique is that a lot of people report having lucid dreams in the brief period of sleep after hitting the snooze button on their alarm. And then finally, the mild technique, which is often paired with the wake back to bed method, entails rehearsing a dream scenario prior to falling asleep and visualizing becoming lucid while focusing on the intention to remember that one is dreaming. And this intention is set through repeating a mantra, which is such as, next time I'm dreaming, I will remember that I'm dreaming. And you repeat this until you feel that the intention has been set. And you keep practicing this visualization technique. And recent studies have shown that combining all these 3 techniques together increases the likelihood of experiencing lucid dreams more than trying them, in isolation. So specifically, 2 studies by Aspi and colleagues show that more than 50% of participants achieved at least one lucid dream over 1 week of practicing this combination. So pertinent to my PhD thesis was the advancement of external stimulation techniques in order to reliably and easily induce lucid dreams. To date, external stimulation techniques have had some challenges and varying rates of lucid dream induction success. This can be attributed in part to the individual variability of stimulus awakening thresholds, big word, as each individual attenuates external stimuli in sleep differently. Therefore, stimuli that are presented in sleep may be too intense, which then leads to awakenings, or too weak to be incorporated. Furthermore, on occasion, when stimuli are successfully incorporated into the dream content, the dreaming brain tends to confabulate reasons about their appearance and then contextualizes them in a way that does not alert the dreamer that they are indeed dreaming. For example, if I dreamt about giving a presentation in Pint of Science, and then as someone flashed lights in my eyelids, then I might see that the light bulb is it might get contextualized in a way that the bulb is flickering, but I may just excuse it as just just the light bulb needs changing. So in my PhD, to improve the shortcomings of external stimulation techniques, I developed a novel external stimulation framework that uses machine learning to automatically adjust speech stimulus properties to the individual, with the aim of presenting stimuli as close to but safely below one's awakening threshold. I used a small wearable device that is worn on the forehead, which has several sensors that measure things like brain activity and heart rate and many more things. The protocol was programmed in a way that was entirely automated, requiring zero input from the experimenter to run. And using this protocol, more than half of the participants tested were able to lucid dream. The technique is still under development, and my goal is to improve this induction rate even further. And potentially this technique could also be implemented in a future commercially available device that could be used for all the applications that we discussed. And I hope you found my talk interesting, and thank you for your attention, and I'm happy to answer any questions you may have.
Thank you, Achilles. I'm sure we'll have lots of people trying to do lucid dreaming in the next few days. So we'll join us in a minute for some Q&As, but first we're going to have a look at everyone's sleeping habits. So let's see what we've got. So we've got some people saying, I used to lie until midday, but as I got older, I've had to do the school run. Yeah, I can imagine that's a bit of a pain when you're a night owl. Any others? So I'm a permanently exhausted pigeon. I think that's all of us really, especially as a student. So what else have we got? I've got any early birds out there? Laura? Laura's an early bird. Yep, definitely a morning person. Brilliant. Any more? Nope, no more. Okay, so, I find it odd that as I've grown older, my feelings of tiredness and desire to sleep don't always match my ability to fall asleep quickly. So we've got Beatrix has also said the same, that you need to get up early in the morning, but if you can't sleep at night, what are you meant to do? So anyone else awake at 3 and return to sleep at 6? Brilliant. So thank you for your contributions, everyone. Now, if we move over to the question and answer session, so if we bring everyone back onto screen and we'll go through some of those questions. Brilliant. So have we got first question for Teo at all? Let's have a look. So, could some of your sleep studies be used to identify ASD children before they exhibit sleep problems?
Yeah, thanks. It's a truly great question, and my brief answer will be yes and no. So yes, because actually this is one of the earliest signs that we see sleep difficulty to fall asleep quite early on, around 10 months of age already. But no, because sleep difficulties are not specific to autism. So we see sleep difficulties across developmental disorders in ADHD as well. So this is actually one of the biggest questions we have to answer. Why do we see like sleep problems across the spectrum in disorders that are so different as autism, ADHD?
Brilliant. Thank you for your answer. So, Joe, are you ready for your first question?
Absolutely, bring it on.
Brilliant. So, what is the advantage of teenage sleeping pattern from an evolutionary standpoint?
Yeah, I think that's a really great question as well. I think we don't know out sort of in terms of definitively, but I think if we think back to before we were all in houses and we could shut the front door and we were safe, one of the things that is really beneficial is to have different people in your tribe or in your group that are awake at different times of day and night. And so actually having teenagers that are awake late into the night and into the early morning to complement perhaps having older adults that wake up much earlier means that perhaps you've always got somebody there and that's sort of available for you in order to make a sign that perhaps you're being invaded or that there's a predator coming or that something is not right. And so I think probably it's not so much adolescent sleep in isolation, but if you look at how sleep changes across the lifespan, one of the factors that gives you is this kind of ability to always have someone awake 24 hours a day.
Fantastic. That's really, really interesting, to be fair. So, Achilles, how accurate are our memories for lucid dreams? Do we know that we happen? Do we remember them? Are they constructed or are they false memory? What are our memories like?
So when it comes to dreaming and whether they are false memories, actually with normal dreaming, maybe that may be harder to answer. But the thing with lucid dreaming is that at least, when studied in the lab, due to this, the studies that we have where there's real-time communication or they are able to send back messages to the experimenter, then it kind of like makes it less likely that lucid dreams are a false memory creation, because there is there is active communication between experimenter and the dreamer in real time.
Brilliant. Tia, are you ready for your next question as well?
Yes.
Yeah. So, slow waves, what type of waves are they? Are they electrical waves? Do they go through the brain? How are they generated?
Yes, thank you. And sorry for having glossed over what these slow waves are. It's not mysterious. Our brain, it's how our brain works, produces electricity. This is how neurons or cells that form our brains talk to each other. So these slow waves are this electrical activity that is generated by neurons, and in this case by the cortex, and that allows information to be passed from one part of the brain to another.
Brilliant. Thank you for clearing that one up for us all. I think we've got another one on slow waves for you. So you said about the wavelength varies. Is that between babies or is that between brains doing different things?
Well, what I said was that there was a range of waves. So it's not necessarily that slow waves will vary in wavelength from individual to individuals, but there are different types of waves in the brain, and there are slow waves and there are fast waves. And the one thing that we know is that how slow these waves are depends on how far the brain regions that talk to each other are. So the farther apart the brain regions that need to talk to each other, the slower these waves are. And the closer they are, the faster the waves are.
Brilliant. Thank you. So Joe, how good or strong is the evidence around the relationship between blue light and melatonin?
Good question. So I think we can say with reasonable confidence that blue light does have an impact on our melatonin. And so we know that partly because blue light is what we get from the sun, and we know that light in general is one of the things that actually helps set our circadian rhythm. So if left in the dark, our circadian rhythm will always be slightly longer than 24 hours. So you get like a sort of free running cycle, and it's having a light dark cycle that helps synchronize us every day. That said, if you are thinking about kind of blue light from screens and things like that and how big of an effect that it can have, I think the jury's kind of out. So I think there has been quite a few studies that show it has some effect. It can also quite often be quite a small effect. And certainly for a long time, we thought, well, perhaps teenagers are more sensitive to blue light, and perhaps that's why they have this shifting sort of sleep-wake pattern. But we found that that's actually not the case. So it might be because they're up later and they're doing stuff in that time, they're more exposed to blue light, but they don't seem to be any more sensitive to it. So I guess my overall answer would be, if you don't have sleep problems, then probably looking at screens and things like that isn't really going to do you much harm. But if sleep is something you're already struggling with, then perhaps setting your blue light filter, wearing blue light blockers, coming away from the screen sort of an hour before bed can perhaps help mitigate against that.
Brilliant, thank you, Jo. I think that in this day and age of technology, we all should be considering. So, Achilles, we've got another question for you. So, is lucid dreaming good quality sleep, or does it actually reduce your quality of sleep?
So it's a good question. Studies have shown that actually it either doesn't impact sleep quality, or sometimes even reports show that it improves. Like people wake up feeling more refreshed after having a lucid dream. However, this depends, let's say we develop a technique or someone spontaneously has lucid dreams in every REM stage, every time they're in REM, every time they dream, all their dream sleep is lucid. That might have potentially that might negatively impact sleep quality. But in the way things are right now, usually people have lucid dreams when they experience them is later in the night, towards maybe their last REM cycle. So toward just, maybe an hour or two before they wake up. And yeah, no studies right now have shown that it's detrimental to sleep quality. But it might be that you get, some people report more lucid dreams, but they also have some kind of concurrent disorder. So some people get sleep attacks, and those people, or some other specific parasomnias, disorders of sleep, and they report more lucid dreams. But it's not the lucid dreams that cause them; they're caused by the disorder. But if you have a normal, healthy sleep and you lucid dream often, then people don't report negative, let's call them side effects. In fact, people who lucid dream more often, they have better mood, they report better mood and better sleep quality.
Brilliant, great answer. So we've got time for one more question for all three of you, and it's a little bit of a funny one. So why do night owls marry early birds?
Yeah,
any speculations?
Maybe it has to do with the evolutionary theory of, the sentinel theory, which is, like with kids, they are awake at different stages. Like the younger you are, then you have a different time that you're awake, and then that covers the older people sleeping during that time. Maybe you create kind of like it's an evolutionary.
Brilliant. Well, thank you. I'm really sorry we haven't got around to everyone's questions tonight, but that's all we've got time for. So thank you to our fantastic speakers tonight, Dr. Teodora Gliga, we've got Jo Bowers, and we've got Achilleas Pavlou. So, and this event would not be possible without a team effort from behind the scenes. So if we bring all of our producers up on screen to say hello, they can all wave in the background for us. Brilliant. So Before the end of this event, there is a feedback form and in the description box below. If you want to enter that, let us know how we did. Did we do great? Can we improve anything? And did you enjoy it? Let us know, and you've got an opportunity to win some Pint of Science merchandise. That's open till the end of June. Don't forget to look at our website, pintofscience.co.uk, and using our Twitter handles to have a look at this year's events. So stay tuned for the next show tonight, and thank you all. Good night.